Hello friends of 3D Max Maker. Today I want to show you how to use a 3D printer to make a repair. This can be applied for any appliance or anything that breaks in your house, and that you can print a replacement part using a 3D printer. In my case, while building another 3D printer, one of the small pieces broke. It's made out of acrylic, and acrylic is pretty brittle. So while screwing it in, I put too much pressure and I broke it. So I decided to print a replacement part using another 3D printer. And this is a good application for 3D printers. While I can get the replacement part, I can buy it online. I have to wait 2 weeks to get it shipped, and I have to spend money, and I have to wait, and I don't want to wait. I want to have the part right now to make the replacement. Since this is made out of acrylic, plastic would be a really good replacement. But what do you need to do to print the replacement part? Since I don't have the model for the part, I have to create the model, export it in a file format that my other 3D printer can understand, and print me a replacement part. So stay tuned in this video and I'll show you the process, how do I do this, and how you can do it. So see you at it. So here we have the broken part. As you can see here in this top corner where I'm putting the screw, it was supposed to be a hole to put the screw through it, but by putting too much pressure on the screw, the top part broke off. So unfortunately, it's nothing I could do. Super gluing it was not an option. So I decided, I'm gonna 3D print a replacement part. This part, the way you put it on the other 3D printer, you have to put this part on top of each other, and then you screw them together. So for the replacement part, I'm just gonna make one piece instead of putting two pieces stacking on top of each other. Because the way they do these pieces out of acrylic, they use a laser cut, and they cut acrylic sheets that have this thickness. So if they need anything thicker than that, they'll have to cut two pieces and put them together. But since I'll be using this 3D printer to print a replacement, I can basically make the piece the thickness that I need. So it also shows that you can use it to make improvements to parts that you already have. So I'm not only gonna print a replacement part, but I'm gonna make it better, hopefully. So what we need to do first? First, we need to take measurements of this part, and it's a good idea to have caliper like this one. This is a digital caliper. It's only $40 at any hardware store, which is a really good price. I mean, I remember these things used to be really expensive. I bet they're still very expensive, the most accurate ones, but for this kind of work you don't need extra accuracy, and these are accurate enough. This is a digital one, so I'm gonna use this to take measurements of the part. I'm gonna make a sketch of measurements and how the part should look like, and then we're gonna go and draw this part in SketchUp. SketchUp is a really good software. So I'll be showing that in the next couple minutes. Okay, so now we're gonna create a sketch to put the measurements for the part, so we can draw it in our computer using SketchUp. So basically the part is pretty simple. It's just a square or a rectangle. It's more like a rectangle. It has 3 holes in it. As you can see, we have one hole here, one hole here, and one on this corner that broke. So basically it will be one hole, 2 holes, and the third hole down here. And in the middle it has this groove, so you can put a screw in and hold the nut, and it'll be holding another piece. At the end of the video I'll show you how the pieces work on the other 3D printer, but for now we're just gonna design it the way it is. So basically it will be something like this, and then it has the groove extends so the screw can go through after going through the nut here. And since this piece is 3-dimensional, this is just the top view, but it can be extruded in SketchUp, so we need to know the thickness in this direction. So we're gonna need to take measurements of all these, the hole diameters, the length, the width, and everything. So let's start measuring. So here I finished taking all the measurements that are gonna help me design the part within the computer. So make sure you take all the measurements that you will need to transfer this design into the computer. So basically I measure the hole diameters, distance between holes, the width, the length, the thickness, so everything, all you need to put this design into the computer. Just make sure you take measurements as accurate as you can, so that way you can create the model for the part. So I'll show you now. I'm going to show you in the computer how I draw this. Okay, here we transfer the sketch into SketchUp. This is a 2-dimensional drawing of our part. Now we need to push it up into the 3rd dimension. In SketchUp you select this tool, and we're just gonna create the 3rd dimension based on the thickness that we want. In our case will be 15.5 millimeters. We're gonna do the same for the other side, 15.5 millimeters, and the middle one we can do 8 millimeters, or maybe a little bit more. We can push it up a little bit more. This is the slot where the screw is gonna go in, and this is where the nut's gonna be holding, and these are the 3 holes used to screw the part to the 3D printer. So basically we're done. This is a pretty simple model. You can make other more complex parts, but for our example here, this is a pretty good part. Now we need to export it to STL. So I'm gonna go to File, Export STL, go Export, and then you put a name for the file. I'm gonna name it Prusa X Belt Hold to STL, because actually this part is used to hold the belt or the X axis.
So I'm gonna go save. I already have another version. It says if I want to replace it, I say yes, and I should have it on STL now. So let's go to our slicing software. In this case I'm using Repetier, and I believe I already put the part in the slicing software just to make the video shorter. And this is our part in Repetier. Now we need to slice it to go and print it. So this is not a tutorial for SketchUp or anything. I just want to show how you can use a 3D printer to create some replacement parts and what the process is. If you wanna go into more detail into SketchUp modeling, there's a lot of really good videos and tutorials on YouTube as well. So there's really good people there teaching how to use it. I'm just using the basic. So I'm gonna slice it at 4mm layer thickness. Go slice, and this is my slice part. This is how it's gonna look on my printer bed once I start printing my part. And it says it's gonna take 7 minutes and 28 seconds to print it. So I'm really excited. I'm gonna get my replacement part today, the same day I broke it. I don't spend any money, probably just few cents worth of filament. And well, this is really good. So see you in a bit. I'll show you how the printing process goes and how do I put the part into the 3D printer.
So here we're getting the printer ready to print the replacement part. So while the printer is warming up, I'm gonna show you how do I prep the printer for printing. Like, one of the big issues on 3D printing is getting your part to stock to the surface while it's printing. So a good solution that I found is using a glass surface. The best way is to use Elmer's glue, the one that kids use at school. So you just spread a little bit on top of the surface like this. My part is gonna be in the middle, so that's where I'm gonna put the glue. And then with a little bit of water and a napkin, like a paper towel or something like that, just put a little bit of water, and then you just rub it off a little bit to make it even, to make an even surface. You just need like a really small layer of glue on top of your glass. And you don't need to use any extra surface, like a brim or anything around your part. Sometimes it's strong enough to hold your part in the bed, so we'll give it a try. Okay, so the printer has been warmed up. The bed is at 60 degrees and the hot end is at 200 degrees. I'm using this setting for PLA. So I'm gonna go ahead into Repetier and hit print, and the printer should start the printing process pretty soon. It's already humming all the axes. By the way, this is a Wilson 2 3D printer. It's a really good design. It's been designed by a guy named Martin. He has some tutorials on how to build your own. He's so far doing a really good job. The main issues when you're 3D printing is getting your bed level and your part stuck to the surface. Once you get some experience, it's really easy. As we see, the first layer is completed and it did pretty good. It's already starting with the second layer. It's going really fast. Well, it's a small part. It's gonna take about 7 minutes to complete. I won't have you guys watching this for 7 minutes, but in the meantime I want to show you one of the other pieces, really cool pieces that I printed with this Wilson printer. Is this maker robot made out of orange PLA. And the cool thing about this robot that I'm showing you is that everything was printed in one piece. Like, I didn't have to do any assembling after. And it came out of the printing bed with all the articulations and everything. It can move the head. And well, the quality is not too bad. I mean, it's pretty amazing the things you can do with these printers. Well, still printing my replacement part, and I'll show you in 7 minutes how it looks like. The printer has finished printing the replacement part. There it is. I'm just gonna put the broken part beside it so you guys can compare. So that is the broken part and this is the replacement part. They kind of look like same size, except that this one is broken on the top. So I'm gonna go ahead and remove it. Hopefully it's gonna be easy to get it unstuck. Wow, that Elmer's glue works really well. I may have to use a knife to remove it, so once I remove it I'll show you how it looks. This is the part out of the bed. It was really stuck to the bed. I think I put too much glue, so I should have put more water with the napkin. Anyways, I finally got it out, and this is the replacement part. So I'm gonna go ahead and put it into the other printer and I'll show you guys how it works. And well, this has been a fun project. It only took me a couple hours or even less, maybe just like over an hour to accomplish, which was way faster and cheaper than buying the replacement. So thank you, Wilson printer. You saved me time and money. This is the replacement part we model and printed. It's already been attached to the 3D printer. As we can see, this is the top part that broke off in the original part. Now, well, this one seems to be a little bit stronger. I guess plastic is a little stronger than acrylic. As I said, acrylic is a little bit too brittle. You have to be careful. On this side we have the original acrylic part. Fortunately, it's still good. So it's attaching the belt on one side. Once it loops around the step motor, it goes to the idler, comes back and attaches again to the carriage that's holding the extruder. So yeah, this part broke off. You know, cannot use the printer without it. Fortunately now, thanks to the same 3D printer technology, we fixed it. So that's what I wanted to show you guys in this video. Again, this technology can be used to fix some other stuff or build your own stuff and, you know, be creative. So thank you for watching this video. If you like it, please put thumbs up. If you don't like it, you can do that as well. Put thumbs down. Leave some comments, some questions. We'll try to put more videos out there. And thank you for watching.